In this video, we'll be going over the double angle and the half angle formulas. First, we'll start with the double angle formulas. Now, the double angle formulas are formulas for how we can find the trig value for double of some input angle. We have sine of 2a, cosine of 2a, and tangent of 2a. In each of these instances, a is some angle. So we want 2 times that angle. So we'll first start with sine of 2a. So sine of 2a, and we will derive this by using the sum formula for sine. So suppose we have sine of 2a. Well, that's the same thing as a plus a. If we recall the sum formula for sine, well, that's just sine of the first times cosine of the second. Now a happens to be the first and the second, so we get sine a times cosine a. Then we keep the sine the same, and then we're going to say sine of the second, cosine of the first. So what we have is 2 terms that are the exact same. So we'd write this as 2 times sine of a times cosine of a. So that is the double angle formula for sine. And then we'll go to cosine and then tangent. So the double angle for cosine, again, we're going to use the sum formula for cosine. So 2a is the same thing as cosine of a plus a. So the sum formula for cosine, we're going to say cosine of the first times cosine of the second minus sine of the first times sine of the second. So again, a is both the first and the second in this instance. So the first term, cosine a times cosine a, is cosine squared of a. The second term is going to be sine squared of a. So this is one version of the double angle formula for cosine. And actually there are 3 total versions. So we're going to look at 2 other versions here. Now let's recall the Pythagorean identity. What we can do is, if I solve this Pythagorean identity for sine squared, I get sine squared of a is equal to 1 minus cosine squared of a. So in place of sine squared of a, I'm going to write 1 minus cosine squared of a. So the second version of cosine 2a is going to be equal to cosine squared of a, I'm just taking this, minus, I'm going to use 1 minus cosine squared of a in place of the sine squared of a. So cosine squared of a minus 1 plus cosine squared of a. So I have 2 like terms here, cosine squared, so I get 2 cosine squared of a minus 1. So this is a second version of the double angle formula for cosine. And then we have a third version. So now let's say I take the Pythagorean identity and I solve for cosine squared. That's going to be equal to 1 minus sine squared of a. So what I can do is, right here, I'm going to replace that with 1 minus cosine squared of a. So with 1 minus sine squared of a. So 1 minus sine squared of a in place of this guy right here, minus sine squared of a. So writing that in a simplified form, I get 1 minus 2 sine squared of a. So I have 3 different versions here. I have 1 minus sine squared of a is equal to cosine of 2a. I have 2 cosine squared of a minus 1 is equal to cosine of 2a. And then we have this right here, cosine squared of a minus sine squared of a is equal to cosine of 2a. So those are the 3 versions for the double angle for cosine. And then we have a double angle for tangent. Tangent of 2a. Okay, well again, this is derived from the sum formula for tangent. Okay, the sum formula for tangent is tangent of the first plus tangent of the second divided by 1 minus tangent of the first times tangent of the second. Well, again, because A is both the first and the second angle here, in the numerator we're going to have 2 times tangent of A. In the denominator we get 1 minus tangent squared of A. So that is the double angle formula for tangent. Okay, so let's see how we can use these formulas. We can use these formulas to verify trig identities. So first we have 1 plus sine of 2 theta is equal to sine of theta plus cosine theta, all getting squared. So on the left side I have the double angle for sine. So that's going to be 1 plus, well, the double angle for sine is 2 sine of theta times cosine of theta. And then on the right, I'm going to go ahead and multiply this binomial out. Running out of room here. But when I FOIL this, I get sine squared of theta plus the inside and the outside terms. I get 2 sine theta cosine theta. And then the last terms, I get cosine squared of theta. Now what we notice is we have a sine squared and a cosine squared on the right-hand side. That's equal to the Pythagorean identity. Sine squared plus cosine squared is equal to 1 plus 2 sine of theta cosine theta, and that's exactly what we have on the left-hand side. Oops. 2 sine of theta cosine of theta. So those are the exact same. So we can use these double angle formulas to verify trig identities, and this is the most common way that we'll use these identities. Another way is to simplify an expression. And if we see 2 sine of 15 degrees times cosine of 15 degrees, well, this is a version, or this is the expanded version of the double angle formula for sine. So the double angle formula for sine is 2 sine of theta cosine of theta. So this, what we have here, looks very similar to what we have here, where theta is just 15 degrees. So because theta is 15 degrees, we can rewrite this sine, 2 sine 15 degrees cosine of 15 degrees is equal to sine times 2 of that angle, 15 degrees. So on the right-hand side, we get sine of 30 degrees, and sine of 30 degrees is just 1/2. So that's what this is going to be equal to. All right, the final example having to do with the double angle formulas is if cosine of theta is equal to 2/5 and theta is in quadrant 1, find the exact values of sine of 2 theta, cosine 2 theta, and tangent of 2 theta. So let's just tackle this first bit of information. We know that theta is in quadrant 1 and cosine is equal to 2/5. So let's draw an angle theta in quadrant 1. Cosine of theta is equal to 2/5. Cosine is the adjacent side over the hypotenuse. So we can find the y value here. We're going to say 2 squared plus y squared is equal to 5 squared. 4 plus y squared is equal to 25. Y squared is equal to 21. So y is going to be plus or minus the square root of 21, but because y is in quadrant 1, we're going to say positive square root 21 here. Okay, so let's go ahead and find sine of theta, cosine of theta, and tangent of theta. I guess we already have cosine of theta, that's given to us, 2/5. Sine of theta, well, sine is the opposite over the hypotenuse, and then tangent is the opposite side, square root of 21 divided by 2. All right, now let's go ahead and apply the double angle formulas to find these values. So sine of 2 theta is equal to 2 times cosine of theta, sine of theta. So cosine of theta we have, which is 2/5. Sine of theta is square root 21 divided by 5. So multiplying this all across, 2 times 2 times square root of 21 is 4 square root 21 divided by 25. So that's what sine of 2 theta is equal to. Cosine of 2 theta, well, we have 3 different versions of the double angle formula for cosine. looking back a few slides, we have this version, and this version. Now it doesn't really matter which one we use. They'll all give us the exact same value. So we could use, why don't I just show what would happen is if we use the first two, and we'll see that we get the exact same value here. Okay, so let's use cosine squared of theta minus sine squared of theta. Well, cosine squared of theta, that just means cosine of theta times cosine of theta. So that's going to be 2/5 times 2/5 minus sine squared of theta. That's just sine of theta square root 21 over 5 times square root 21 over 5. So multiplying that out, I get 4 over 25 minus square root 21 times square root of 21 is 21. I get negative 17 over 25. Now let's go ahead and also I kind of box things off here. Let's say I use a different version of the cosine double angle formula. Let's use 2 cosine squared theta minus 1. So we're going to have 2 times 2/5 times 2/5 minus 1. That gives us 8 over 25 minus, well, 1 if I get a common denominator, that's 25 over 25. So that's also negative 17 over 25. So whichever formula or version of the cosine double angle that we use, we end up with the exact same value. Alright, and then let's go ahead and find the double angle for tangent of theta. Well, we already saw that tangent of theta, what was that equal to? Square root of 21 over 2. So square root 21 over 2. So 2 times tangent of theta is square root 21 over 2 divided by 1 minus square root 21 over 2 times square root 21 over 2. In the numerator, the 2's cancel, we get square root of 21. In the denominator, we get 1 minus square root 21 times square root 21 is 21 divided by 4. So we need to simplify this fraction. I'm going to rewrite 1 as 4 over 4. Hang on. Need to write the numerator, square root 21 divided by 4 over 4 minus 21 over 4. And the numerator, square root 21. In the denominator, 4 minus 21 is negative 17 over 4, like this. And so I have square root of 21 divided by negative 17 over 4. That's the same thing as square root of 21 times the reciprocal 4 over negative 17. So we end up with 4 square root of 21 divided by 17, and it's going to be negative. So that's how we find the double angle value for tangent of theta. Next, let's look at the half angle formulas. Now the half angle formulas can be used when we want to find something like cosine of 22.5 degrees. Now 22.5 degrees is not a value that is known on the unit circle, but instead if we rewrite cosine of 45 degrees divided by 2, well, 45 degrees is a value on the unit circle, so we can use the half angle formula to rewrite something like 22.5 degrees into 45 degrees divided by 2. We can use the half angle formula to evaluate. So I'm going to go ahead and prove the half angle formula for cosine. So suppose, let's first think about one of the double angle formulas for cosine. So cosine 2 of theta is equal to 2 cosine squared of theta minus 1. Now what we're going to do is we're going to say let theta be equal to 1/2 of, let's pick a different angle, so let's say beta. So what I'm going to do is I'm going to replace the thetas with this 1/2 of beta. So cosine 2 times 1/2 beta is equal to 2 cosine squared 1/2 beta minus 1. So on the left, 2 times 1/2 is just 1, so I get cosine of beta is equal to 2 cosine squared times 1/2 beta minus 1. So ultimately, we want to end up with cosine of 1/2 beta. So I'm going to try to isolate this cosine of 1/2 beta on the left-hand side. So I'm going to add 1 to both sides. So cosine of beta plus 1 is equal to 2 cosine squared 1/2 beta. We'll divide both sides by 2. And then we'll take the square root of both sides. So on the right-hand side, we're going to end up with cosine of 1/2 beta, which is the same as beta over 2, is equal to, well, when I take the square root, we end up with plus or minus. So this is cosine of beta plus 1 divided by 2. So this is the half-angle formula for cosine. So thinking back to what we saw up here, so suppose we were wanting to find out what cosine of 22.5 would be. What we would do is we'd insert in place of the b the 45 degrees, or in place of beta 45 degrees, and then over here we'd also replace that with 45 degrees. So 45 divided by 2 on the right hand side would give us 22.5. We'd use that formula on the left to help us find that value. Now, one note about the plus minus here. The plus minus depends on the quadrant of beta over 2. So suppose we were using 22.5. That's what we were trying to find. Well, 22.5 is in the first quadrant. Cosine is positive in the first quadrant. So if we were trying to evaluate cosine of 22.5, we would use a plus here. However, let's say we were looking for cosine of, I don't know, 157.5. Well, that is in quadrant 2. Cosine is negative in quadrant 2, so we'd use the negative. All right, so here are the 3 half-angle identities for cosine, sine, and tangent. So we derived cosine already. We can derive sine in a very similar way. And then for tangent, well, we know that tangent is just sine over cosine. So sine 1 minus cosine of b over 2 divided by 1 plus cosine of b over 2. The 2's would cancel, and that's how we end up with what we have down here. All right, so in practice, we don't use these as frequently as the double angle formulas. So I'm just going to give one example on how we can use these formulas to find the value of an angle. So let's find the value of cosine of 157.5 degrees. Now, the first thing to notice is that 157.5 is not one of the values on the unit circle. But if we do 157.5 degrees times 2, we get 315 degrees, which is a value on the unit circle. So in other words, we're going to use the half angle, I keep writing 2's instead of 3's. We're going to use the half angle formula for cosine. So cosine of 315 degrees divided by 2. 315 divided by 2 is 157.5. So 315 divided by 2, that is 157.5 degrees. That is in quadrant 2. Okay, so instead of writing the plus or minus for the square root, we're just going to write the minus. Okay, and let me just write the whole formula first. So the formula is going to be 1 plus cosine of 315 degrees divided by 2. So again, we just want the minus of this. So minus square root 1 plus cosine of 315 degrees, that's quadrant 4. Cosine is positive in quadrant 4. It's going to be positive root 2 over 2, all divided by 2. Now, this is going to take a little bit of work to simplify this. So what I can do is I can rewrite the 1 as 2 over 2. So negative of 2 over 2 plus square root of 2 over 2, all divided by 2. So in the numerator, I get 2 plus square root 2 divided by 2 all over 2. Okay, so I can I have a complex fraction. I can rewrite this as negative square root of 2 plus square root of 2 all over 4. And because this fraction is all under the square root symbol, I can take the square root of the numerator and the denominator separately. Now the square root of the denominator is just going to be 2, so I can take that 2 out of the square root symbol, and we end up with square root of 2 plus square root 2 all over 2. Now this doesn't look very simplified, but this is as far as we can go. It's more simplified than what we had down here because we don't have any complex fractions. Yeah, so that's how we use one of the half-angle formulas. And here are all the formulas that we looked at in this video. The double angle formulas for sine, cosine, and tangent, and the half-angle formulas for cosine, sine, and tangent.